Well, we have another question here, question 5. Well, the question says, the sketch below shows the graphs of f of x, which is given by 3 over x minus p plus q, and g of x equal to 2 to the power of x plus r. Now, g of x, I mean, g is G intersects the vertical asymptotes of f at A, and B is the common intersection of f and g, and then y equal to 2 is the common horizontal asymptotes of f and g. Now, question 5.1, as we can see, says write down the value of r. Now, right here, just highlight question 5. We need to write down the value of r. All right, r is here. So I'm gonna write here question 5.1. 5.1, r is what we need to find. Now, r is r being here in this exponential function. We know that this is the horizontal asymptotes of the I'm gonna abbreviate it like that, horizontal asymptote of the exponential function. So we can see that the horizontal asymptote is over here. This is visible from the graph here. We can see that the horizontal asymptote, and then it passes through these points here too. Then we can just say r equal to 2. R equal to 2, because it is the horizontal asymptote of g. Okay, and the question also says here that 2 y equal to 3 is a common horizontal asymptote of f and g. So r is just equal to 2. Now, question 5.2, the question says determine the value of p. Now, I'm gonna write here p. If you look at in the question, p is there by f of x. So f of x is an hyperbola, and then we know that this value of p stands for the vertical asymptote and q for the horizontal asymptote. So here we know that this is a vertical asymptote, and then q is the horizontal asymptote also. Now, we must know that all these are common, are the same, they're just equal to 2, because it is given there in the question, the common horizontal asymptotes of f and g. Now, excuse me, we can rewrite the function that is given by 3 over x minus p plus q can then be written as y equal to 3 over x minus p. Instead of me writing q, I just want to say plus 2, because that's the value of q now. Now, if we need to find p, what can we do? Let's see in the question, is there anything that we can look at and then help us find q? Okay, if we look carefully, we can see that there's a point here, b, that lies on both functions, f and g. And then another thing is that b is the intercept, okay? And it is the intercept of both of them. So they both intersect at b, and they also, you can see here, it say b is a common y-intercept of f and g. Now, what does it mean by x-intercept? Over here, x-intercept simply means, algebraically, it means make x equal to 0. So over here, we do know that x is just equal to 0. Now, I'm going to select the equation. In the 2 equation, I'm going to take g of x, because g of x, we know g of x which was expressed by 2 to the power of x plus r. Now g of x is 2 to the power of x plus 2. Okay, because we find the value of r. Now, if I need to find then the y-intercept, it means I'm going to make x is equal to 0. Okay, so this is going to be y, and then x is going to be equal to 0. And then this is just y equal to 2 to the power of 0 plus 2. And then that makes y equal to 1 plus 2. And then which means y equal to 3. Now we have the point B. The point B is the point 0, 3. This point here is the point 0, 3. Now we have a point, and we also have one of the asymptotes, the horizontal asymptotes, so we can find P by substitution. Okay, B being equal to 0,3, I'm gonna sub B here, sub B 0,3. The equation y, equal to 3 over x minus p plus 2 will then be written as y equal to, we can sub in the points. I'll sub the points 0, 3, so 3 for y, and then 0 for x. So this will be like 3 equal to 3 over minus 0 minus p plus 2. So if I move these 2 over, okay, and then this will become 3 minus 2 equal to 3 over 0 minus p, just negative p. And now this makes 1. 3 minus 3 is 1, equal to 3 over negative p. And then by cross multiplication, because 1 here can be written as a fraction, right? So we can cross multiply 1 with p, and then 1 times 3, and then this will just make negative p equal to positive 3, therefore, which means p equal to negative 3. So p is negative 3. Okay. P is negative 3. Now, that was the value of p. And then question 5.3 over here says determine the coefficients, the coordinate of A. Now let's see, A is just a point here on this function, or on G, okay, on the exponential function G. So if I need to find the coordinate of A, we can notice that the x coordinate of A is the vertical asymptotes, okay, because it lies where the dashed line passes. So here, over here, we did find earlier that P in 5.2, that P is equal to negative 3. So the x coordinate of A is negative 3. So we can just substitute negative 3. This negative 3 here in G of x in order to find the y corresponding value, and then we got all the coordinate of A. And I'll move my board, I'm gonna move it over here. Let's just split like this. Okay, 5.3. We're looking for the coordinate of A, the x and the y coordinate of A. Now, we say that the x coordinate of A is negative 3 because it lies on the excuse me, on the dashed line, the vertical asymptotes, the vertical asymptotes of f. So negative 3, we can then do, because g of x is given by 2 to the power of x plus 2, we can sub in negative 3 there. Okay, so g of x is just y, so it's going to be 2 to the negative 3 plus 2. And then this would be y equal to 1 over 2 to the power of 3 plus 2. Okay, that makes y equal to, okay, I'm going to write it here, y equal to 1 over 8 plus 2. And then that makes 2 and 1 over 8. That's the y coordinates of A. So we can see A is just the point negative 3 and 2 and 1 over 8. Voila. And then the following question is question 5.4. Let's see. 5.4. The question says for which value or values of x is f of x minus g of x greater than or equal to 0. Well, we can just see it from here. excuse me, f of x is f of x minus g of x is greater, excuse me, greater than or equal to 0 in this interval here. We can notice that this is f of x, and that one is g of x. This is where the difference is more than 0, because the difference is this, is on the positive. Excuse me. Okay, over here, it is g of x minus h of x, but here it's f of x, because that's f of x minus g of x, and it's positive. Because when we talk about g of x minus g of x and f of x, we're referring to the y values. Okay, so those values that we see, those arms of the hyperbola and this portion of excuse me, of the exponential function. Now we can see it is positive only this part. So the interval over which it is more than 0, which is positive, is from this point to that other point. Okay, so from -3 here, actually from -3 to 0. So we can say over here from 0 lesser than, or actually from -3 to 0. Okay, from -3 lesser than or equal to x, lesser than or equal to 0. So in this interval. Now the following question that says 5.5, if h of x, okay, I'm going to highlight here, if h of x equal to f of x minus 2, write down the equation of h. So in this situation, I can just do it here. It simply means wherever you have x, substitute by x minus 2. Okay, so this will be then okay, f of x, which was given by 3 over x minus x plus 3, because p is -3, and then plus 2. Okay, now we're going to write f of x minus 2 like this. Okay, we are going to substitute x minus 2, x minus 2. Then this will become then f of x minus 2 equal to x excuse me, x minus 2 plus 3 is just +1, so that makes +1, and the 3 there plus 2. That's the equation of h of x. So this is h of x. So something like that. Well, thank you.